Welcome to the third episode of Let's Make a Game platformer. In last episode we have managed to get to the point where we can display a sky blue background in our game, as you can see here. Because it's a platformer game, then maybe let's today work on actually displaying some platforms. So in previous episode I tried to start explaining what the ECS is, so the Entity Component System, are. I do realize now after watching it that I made a really horrible job at explaining this. So rather than doing it again and doing a bad job again, I'd rather post a couple of links in the description of this video where you can read all about the entity component systems, and so that you have at least some kind of reference on what it is and how to use it. So starting from this episode, I'll assume that you have some understanding of the components and entities and how it all ties back into the whole game programming. So as I said, today we'll be working on rendering some platforms. So let's start with adding a new class, platformer, and environment renderer, and it's gonna implement an environment renderer. So environment renderer is something that is part of the 5-phase master renderer. One of the steps is drawing the environment, as you can see here. So that's what we're going to be implementing. That's where we want to render it. So we will say that this is register system. So this is a system that should be picked up during context initialization, and we want to inject into our class the environment renderer registry, so that we can register this renderer. We want to implement life cycle system so that we are notified of events. And here override public void initialize, and in the environment renderer registry we want to register this and override in destroy. We want to deregister. Other one doesn't support it, so we don't do this. So let's just delete this one. Okay, so now we are registering ourselves for rendering, and we have to implement the method that it okay, so the environment renderer interface has two methods. One, render environment for light. This is something we will skip for the time being. This is something that you might add later on once we work on shadows. And the second method, which is render environment, which is actually actual rendering of all the stuff you want to do. And we are passed a lot of stuff here. We will, for now, only use the camera object here. So how the rendering is done in the libgdx, the GDX library for 3D rendering, is that we have to have a model batch. Well, we don't have to. This is one of the way of doing this, and I think this is the easiest one. Override private public void pre-initialize. So just after the class is created, we want to create a new model batch, and in here we want to, so let's take a look at one of the backdrop renderers, how it's done. If you take a look, we have this is how we basically call something. So we call a begin with a camera. Let's maybe just copy this to our class. And in here we'll be rendering our model instance. And let's initialize also model here. So, okay, so let's now maybe explain what these objects are. Model batch is something that helps improve performance of rendering stuff. So if you, for example, render multiple objects, they will be queued together, and the model batch will try the most efficient way to pass this information to the graphics card to render it. Model is something that contains geometry and defines geometry, so how the vertices are and what's their positioned in how they are positioned in regards to each other, while model instance contains a reference to a model and can contain some transformation on top of it. So if you can imagine, let's say you are playing an old-time asteroid game where you had multiple spaceships, and you would have all the spaceships look the same. So that will be one model for all of them. And each spaceship that's actually rendered to the screen is separate model instance with its own positions, own rotations, or whatever you might imagine having there. So we have to create both of them, where model is actually something that resides on the graphic card in graphic card memory, which is why it has to be disposed. So let's maybe quickly create the model. Let's for now use model builder for this. To just show one way of doing this. You can create a model builder, and model builder, let's go with create box of size 1, depth 1, material for box. Here we'll pass color attribute, create diffuse, let's make it red. So we'll be creating that material for the box is just solid red. So in here we pass the box material, and attributes will say vertex attributes usage. So we want to have position, sum it up with vertex attributes usage, normal, and we have to pass the colors usage color packed. Okay, so this creates a box, so this creates a model. So our model is this, and model instance, new model instance model. So now we also have to make sure we got, so the model is something that we have to, because this resides on the graphic card, we have to make sure that we dispose it. So override post destroy model dispose. Okay. So in here we will just render model instance, and I think that might be actually it. So let's try to run this and see if it works. Yeah, so we have something that is displayed, a red box. So what else we can do here is specify the location to be location. We do it by saying transform matrix 4, and we want to translate it by a bit down, so 0, -2, 0, because up and down is y coordinates of the second one. So let's run it again and see if it works. Okay, now we are having this box little. Now we can see it's actually a box, even though there is no shades yet. But as I said, we'll work on shadows and other stuff like that a bit later. So this is how we can create one box. So if you wanted to have another one, we can just say in here we're gonna have a list of model instances. And let's make here new linked list other instances. Instance. Let's do it this way. Let's rename it to instance 1. We'll copy this. Instance 2, and we move it along x-axis by, let's say, 2, so we have a bit of space. And here we can pass an array of a collection of the iterable of model instance. So we can pass this one. Now we just have to make sure we add them both to the list. So instance 1 and instance 2, and let's run it. Okay, so we have now 2 boxes. So that's how you can use the same model for multiple things so that we only store this once in a graphic card memory rather than having multiple. So you can then rotate this, you can pass whatever transform you want here. Okay, but what we are going to actually be using is something different. So rather than using the model builder, so the problem with model builder, and I hope they fix it in some future releases, is that this class has to be used from the main thread of the application. So if you wanted to load something in the background, some model from, or create some model in the background, just extensive, like multiple platforms or the whole level or whatever, you cannot do it in the background. It has to be done on the main thread, which means that the application is going to freeze for the time being while you're building this. This is why I created my own class for this, sort of a helper class, which is called array vertex output, which allows me to do the similar things like the model builder, but do it in a separate thread. So let's start off with, rather than having material like this, we will be using, first of all, texture atlas. And so maybe let's start with this. So active profiles, add texture atlas. So what texture atlases are? So whenever you want to use an image in a 3D graphics in OpenGL, you have to load the image to your graphic card, and whenever you want to use it, actually render using it, you have to tell the graphic card, now I want to be using this one. That means that if you are having, imagine having multiple different images, like, so I uploaded here a couple of ones like dirt, grass, side of grass, and stone. So if you want to have these to render your platforms or your level, you have a choice of either using them as separate files and switching one by one to the graphic card. So I'm saying, now I want to draw using the dirt, now I want to draw using the stone, and so on and so forth. This is, however, going to be very slow because every switch of this image is a separate call to the graphic card that has to be synchronized. So your CPU has to wait for the graphic card to finish using the last one, and you have to wait for it to switch to this one. So this is very slow. So what is a very common technique in 3D rendering is that rather than using separate files, like here we have 4 files, you actually create a one larger image containing all those 4 files, and just saying I want to use this big image. However, for rendering this particular triangle, I want to use this part of this image and this part of this image that contains some stone or the dirt or grass texture. So what this big image is called in very commonly in many different APIs is texture atlas. So we have it here, one here, and let's use it here then. Inject texture atlas. I'm sorry, not texture atlas. Texture atlas registry, which is where we are gonna be registering the texture that you want to use. So let's go with here texture atlas register texture, and here we specify the name of the atlas. So let's call it platforms. And in here we can pass block tiles / dirt png. So for now just one. And this registers the texture, and then when we want to actually use it, so extract the texture from it, you have to use provider, which allows us to get the texture. So first of all, due to how the everything is loaded and the texture is initialized, we have to do sort of a lazy building of the model instance. So let's get back to the model instance here, and let's, instead of model instances, call it terrain model, maybe just terrain. So we'll be drawing terrain here, and in here, if the terrain is null, you will say initialize terrain. Okay. So as another step, we'll just create a terrain here. So first of all, from the texture atlas provider, let's get texture platforms, the texture atlas ID, and the name of the texture is block tiles dirt png. This gives us dirt texture. So another thing we're going to be using here, apart from the texture atlas, is a shape provider. So what this class is, so imagine you have like slope, like for platformer you will have like slopes or cubes for rendering platforms or some other kind of shapes you want to display on the screen. It would be silly to like write the code for with all the coordinates every single time. So instead, what we can use that is in the gaming module is the shape stuff. So here, which basically describes a cube. This one is it's a JSON file that describes a cube. Specify that it has a top side with these vertices, normals, coordinates for textures, and so on and so forth. So we'll be using shape provider here, and from shape provider we can say shape provider, we want to get the cube. And now let's use the array vertex output vertices, and we can do shape output. You can say vertices, and we want to pass a cube. And in here we have texture region mapper. So let's for now use new fixed that's texture region mapper. I added it on a different computer. Let me just update it quickly. Okay. So fixed texture region mapper, and we will be using dirt. And we don't want to move. We will move it to the bottom, and that's it. And now we will be doing vertices. From the vertices we already have, we will generate mesh. Let's call it terrain or platform. This really doesn't matter at this point. And then we do mesh. Sorry, not mesh. Model. Model builder. Oh, jeez. So we're back to using model builder, but with already pre-built stuff. Part, platform, and material. So in here we'll be using texture attributes, create diffuse, passing a texture. So what is important here that we are getting a texture region here. So as I said, we have this whole atlas containing multiple textures, and we are only specifying that we want to draw this shape using this dirt texture, part of the big texture image that shows only the dirt one. However, when we want to render it to using J3D, we want to pass the whole texture rather than only the small part that uses dirt. We want to pass the whole texture atlas. So that's why we have to here pass the whole texture that has the dirt in it. So we pass the material here, and terrain. So this doesn't return anything. So we have to, since we are building our stuff from scratch, we have to begin and terrain model builder, and so this returns model. Getting ahead of myself, and then model instance. So terrain model instance model. Okay, and we are disposing it here. Okay, so let's run it and see how it goes. Okay, we have a new pointer. This has to be initialized. So, as I said, these methods are. This is the method that's called after all those are injected. So this was null at this point, but once you move it here, it should be fine. Okay, so we have a dirt block. Awesome. So now let's do something more complicated. So we want to use this grass and grass side and dirt. So this is similar to Minecraft, if you've ever seen. So let's load all of them. So we want to here have block tiles grass PNG and block tiles grass side PNG. So we'll have all those blocks here. We'll extract all of them here, grass and grass side PNG. Grass. And now question is, how do we assign them here to this shape? So the way you do it is by using the texture region mapper. So in here, so each shape, as I'll show you here quickly, says that the top side of the cube is rendered with those texture IDs. So first it will try to this interface. First will be called, for the top side, will be called with the top string. If this method returns null, it will be called with top and bottom. And if it will be null, it will be called with all, which means that you can specify that. And the important part, for example, here is that the back, which is basically something that is behind the block, is returned with sides, which is going to be what we're going to be using. So let's do it quickly here. Let's create a map of string to texture region. Texture ID for grass. And let's say that for the top side, we want to use grass. For the bottom side, we want to use dirt. And for the sides, we want to use grass side. And in here, so the fixed texture region mapper, we'll be using map texture region mapper. Okay, and so let's run it quickly. And let's see if we are able to correctly render the block. Yeah, it seems to be fine. Let's move it up a bit so we can see the bottom of the block as well. So let's move it, instead of down, let's move it up and a bit to the side, so we also see the side of the block. I think I moved it a bit too far, but as you can see, there's the side of the block and the bottom of the block. Okay, let's maybe, the blocks are a bit too large. Let's maybe move our camera a bit closer. Distance from terrain. So we have this class that's setting up the rendering camera. We all, at the moment, it was 5 blocks, so 5 units away from the terrain. Now move it a bit further away, so the blocks will be a bit smaller, and we should be able to see the block better. Okay, so now we are seeing that indeed our block was correctly rendered. So what else we can do here that is fun? So another parameters here is that you can specify that you want it to be larger. The platforms, for example, wrong place. We want to scale it on the x-axis by 2. That way it will be maybe by 3. And bring it back to the center of the screen and a bit lower. So if we pass 3 to the multiplier, we'll be seeing a wider platform. Yeah, so we are seeing a platform which is a bit wider. The problem now here is that the texture gets stretched, which is not something that we want to have. There's a couple of ways we can fix it. The way I prefer to approach it is just, rather than having one large block for the platform, I'd rather have 3 blocks sitting next to each other. So what we can do here is just specify that it's going to be 1, 2, and 0, 1, and 2. And let's put it a bit lower so we see the top of the block. That way we'll be easily able to see nice texture and we'll still achieve what we want to achieve. Have nice texture visible here. Okay, so now let's take a look what actually is the, quickly look at the atlas that is generated. It's generated in a temp folder here. We have something that describes the atlas, so it says that it has a dirt, grass, and grass site, the position of it. You don't really have to look at it much. This is the interesting part where you see all the images that were here used are actually one image that is being loaded into graphic card memory. But this is done everything automatically. You don't have to think, you don't have to create this file by yourself. It's done automatically for you. So this is how we can render multiple platforms this way. In a next episode, I will show how to do it much more efficiently without us hard coding everything in the code. And instead, we will have a separate file that will contain this information, and during the runtime, we'll load this file and create the mesh, so the platforms from that file. Okay, that's it for episode 3. Thanks for watching. Bye.